So let's talk about the specification. So selected products must be appropriate for the selected application. So for example, if you're writing a specification for a tiled rooftop balcony or deck, it's going to be different to the specification or the product specification of an exposed membrane system. And then it's going to be different again depending on the amount of traffic it's expected to get. If it's render, likely to be a different membrane again. If it's going to be a green roof, I guarantee it's going to be a different membrane. And planer boxes also need different membranes. And the installation of the system though is generally going to be the same, or the detailing, but the product specification is going to be different for each and every one of those jobs. So let's talk about compatibility. So the substrate has to be compatible with the primer. The primer then has to be compatible with the membrane you're going to put on top. The membrane then has to be compatible with the tile adhesive. And the tile adhesive then obviously also has to be compatible with the tile. And the entire system has to be capable of accommodating the expected movement. Make sense? So here's an example of a membrane that wasn't overly compatible with the primer used. Basically pulled straight off. And here's an example of a waterproofing membrane not compatible with the tile adhesives. So I can tell you now that's a moisture cured polyurethane membrane, and no, you can't stick tiles directly onto them, it's going to fail. And of course the other thing that's very important with substrates is it's got to be clean. Right? So you can't ring the manufacturer up saying your bloody membrane's not sticking to the concrete, and then we pull the membrane back and it's mud on the bottom. Right? Also it doesn't work. So I mentioned earlier class 1, 2 and 3 membranes. I'll give you a little bit more detail on that. So a class 1 membrane has less than 60% elongation. Class 2 membrane has between 60 and 299% elongation, and a class 3 membrane has more than 300% elongation. Right, so what that all means is elongation basically is the ability of a membrane to stretch, or of the correct thickness to stretch without breaking where it is not bonded to the substrate. Okay, so you'll hear us talking about bond breakers. Bond breakers do exactly that. They break the bond of the membrane to the substrate so the membrane can move and stretch. So the classification of the membrane, especially internally, determines how to design the bond breakers at critical junctions. The bond breaker design for each class of membrane allows for around about 5 millimetres of movement without any detrimental effects to the membrane. All right, so therefore, membrane classification should not be used as a primary factor for choosing the waterproofing system. So for a particular application, a class 2 membrane may well do a better job than a class 3 membrane for a particular job. You just have to do the detailing properly. All right, so don't think just because a membrane's class 3 rather than class 2, it's going to be a better product for that particular application. So how bond breaking works, just so we got a membrane wall floor junction, and we basically do a 90-degree corner. So the membrane's basically attached everywhere. A little bit of movement, membrane just tears. Okay, and that's kind of what you'd see on site. It doesn't take much movement if you don't have a bond breaker. If you have a bond breaker, which quite often, well, the only true bond breaker really is NutriCure silicone. Quite often people use polyurethane, which also kind of works. What happens is the membrane's now bonded to the substrate up to there and to there, and you get some movement, membrane lets go from the bond breaker and it can stretch. Yes, it'll get thinner, but it's unlikely to tear unless you get excessive movement. Okay. There's some newer products on the market. Have you guys heard of hybrid polymers or MS polymers? They're basically a combination of silicone and polyurethane. They work a little bit different because quite often the membrane actually bonds to them. Right? And generally they move with the membrane. Right? The ideal way, so you have no issues or less likely even than that to have issues, is to use the joint tape with a rubber embedded inside the fabric. Do the detailing with that. Then you can eliminate the bond breaker, it'll do the same job. And what you can't do is put masking tape in that transition. You will just about always get that. So for external waterproofing, what the standard says, it calls them fillets in generally, and there's a lot more sheet membranes used externally, so it makes a distinction. So for a sheet membrane, you need a 40 by 40 millimetre fillet at any transition. And by fillet, it's basically a triangle made from, you can make it out of cement grout, 40 mil high, 40 mil on the ground, cut it off diagonally. And it gives you a nice transition, and that's for sheet membranes. For liquid membranes, it asks for a bond breaker of 15 by 15 millimetres externally. Any questions so far? So let's talk about drainage design. Very important for external waterproofing as it is for internal. So the external waterproofing standard says the membrane shall be connected to the stormwater drainage system through a downturn of the membrane into the inlet of the system. So what that means in short, you've got a pipe coming out of the concrete for your drainage, cut the pipe off, turn the membrane down. All right. This is where it's completely different from the internal waterproofing standard. All right. The alternative connection is through puddle flange. So internal waterproofing standard says you must use a drainage flange or puddle flange for your drainage connection. The external waterproofing standard gives you both options. All right. Believe it or not, the standards are actually written by two different committees, so that's why the difference. AIW's advice, use a puddle flange or a drainage flange everywhere and make sure they're recessed. All right. And the other thing is, which a lot of people often forget, is they're made from PVC generally, so you need to use a primer, specific primer for PVC, to make sure the membrane sticks to it. All right. Because when you think about it, generally if you're on the building site, someone wants a clean bucket, they get the waterproofer's bucket, let the membrane go off and peel the membrane out. Well, the puddle flange is made from exactly the same stuff as that bucket. So it's not going to stick unless they have specific primers. There are some membranes, I know, Shane, that'll stick to the PVC on their own, but 99 times out of 100, you will need a specialist primer. Okay, all make sense? And the whole idea is you need to allow for subsurface drainage at the membrane level. All right. And you'll hear me talk about this quite a bit more during this presentation. So subsurface drainage at the membrane level. For exterior compressed fibro decks like Skyon, your BGC board or Durafloor, they must always drain to the outside edge of the balcony. Right? That's not from the standard, that's from the manufacturer's installation manuals. So anything CFC based has to drain to the outside edge. They cannot drain to a floor waste in the centre of the deck.